Now, so that once we understood how it works, then I'd like to discuss some of the tools that are important for us, which you'll be using on your basically homework for, which comes after this one, okay, the third one, on optimization. So in this case, what do you optimize? How do you optimize things? Now, the first thing that you should do is you should measure how much compute time does it take, okay, by your code, okay. So most modern machines have some built-in cycle counters, okay. So, but using them to get reliable measurements is tricky because, as you will see in the operating system's course, the computer actually is switching between multiple program executions at any time. Okay, so getting basically the cycles is actually not very straightforward. And what we would do is we would basically do what's called a profiling on how many times it's been called, and using a Unix tool called gprof. And what we do is, and this is the part that we will look at it. And then, the second thing is, whenever we have some code, okay, and we will try to generate the assembly code and see basically what optimizations has the compiler done, okay? And then, if there are some unexpected things, then we can help the compiler to compile in a certain way. So here's basically like there was a simple example, which the task was, for example, to count the word frequencies in a text document and then produce sorted list of words from the most frequent to the least. And its steps were convert the strings to lowercase, and we have discussed this at the beginning of our discussion on optimization, and then apply a hash function and then read words and insert into a hash table, okay, which are mostly list operations, and then the sorting results, okay, and here's the data. Now with this, the output, what we expect is, for example, for Shakespeare, that you want to say that the was used 29,000 times and was used in as, etc., etc. Okay, this is the output that we are expecting. Now, what we will do is we want to basically, once we run our executable program, then we need to compute the amount that's spent in each function. Okay, we have a lot of different functions, and the way it works is, once you compile your code, and actually you'll be compiling this with certain flags, okay, that basically when you compile it like this, okay, it will generate an executable, and once you run this executable, then in this it would periodically interrupt the program, okay, and see what function it's currently executing, and then it increments its timer interval, basically timer by the interval, okay, and it also maintains a counter. And its output, then you can see the output of this basically this profiler. And for example, this is like when you look at this profiling code, you would see that, for example, the function like sort words, okay, is actually it's spending say 86% of the time of your execution. And then this is the lower function, find the element frag, etc. You can see that there we have a serious problem, that this is where I need to optimize. Okay, and then you can say that and then you can look at your sort words function, and you may realize that you are using an inefficient sorting algorithm. Okay, and then you can then, for example, use a more efficient, like say using a Q-sort. Then with this, then you can actually, in the initial case, you are using sorting here, okay, and after using, for example, a Q-sort, then all of a sudden, like these are the different functions that were taking my time, and you can see that the time is getting much less, okay. And in here, then you can say maybe this is the part on the list, then you can focus on the next biggest one. Okay, you should think of in terms of the algorithm, in terms of the data structure, and so on. Okay, so these are the further optimizations. I'll suggest that you read the book on this to see the details. Okay, so I will just skip this, and so here's the basically how you get this high performance. This will be your, again, homework 4. The fastest, okay, the fastest code will win. Okay, so you will be, again, competing with each other. And the first thing that you should do is you should use good compiler and flags, and don't do anything stupid. Okay, where look at your hidden algorithmic inefficiencies, like we have seen is in the lower string, lower function that we've done. You should write a compiler-friendly code with the look about optimization blockers, procedure calls or memory references, and also you should focus on the innermost loops where most of the work is done. Okay, and then once you get it right, then you should tune the code for the machine. Okay, and we have seen how much computation power that you have in a superscalar basically processor. You should try to exploit the instruction level parallelism, avoid any unpredictable branches, and then make code cache friendly. Now, this will be the topic that we will start on Thursday next week.